Hello students, this is Dr. P. Shekar, Assistant Professor, Mathematics Department. Today we shall discuss the concept of integration, methods of integration, which is very important thing in ordinary differential equations and vector calculus. So what do we have? The methods which are frequently used in integration. So first one among them is integration by substitution. So it is very often we see the function which is to be integrated somewhat difficult, which cannot be directly integrated. So just upon replacing the complex function or the difficult function by some variable that can be converted into a simple form, then only it can be integrable. So by method of substitution, we can do the given integral. And the second one is integration using partial fractions. So this is one another alternative where we can split the given function into two or more number of terms. Then we can separately integrate the terms. Third, also very popular, integration by parts, or also called as UV rule, integration of UV rule. So this is also one of the popular method which we gonna use more frequently in integrating the functions. So let us discuss all this one by one. So let us stick to the first one, integration by substitution method. So let us illustrate this with one example. So as you see, the function to be integrated is 2x into sine of x square plus 1. So this cannot be integrable directly, but we can connect these two, x square plus 1 and 2x dx. So as you know, x square plus 1 differentiation is the 2x. So let me replace or substitute x square plus 1 by some t. Then on differentiating, x square derivative 2x dx and derivative of t as dt. So now we can replace these two here in the given integral. So it will become integration of sine of x square plus 1 as a t and 2x dx as a dt. So now the given integral 2x into sine of x square plus 1 dx becomes simple sine function. And as you know, integration of sine function as minus cos t. So it is only minus cos t, as this is indefinite integral. What is indefinite integral? The integral without limits. So it is to add arbitrary constant c. And the function given to be in terms of a variable x. So even after the integration also it should be in terms of x. So for that, let me substitute back what is t. What is t? T is x square plus 1. So it is minus of cos of x square plus 1 plus c. So this is what the integration of 2x into sine of x square plus 1 dx. Let us illustrate the same by considering one more example. So what do we have? Integration of sine of tan inverse x divided by 1 plus x square dx. So when we look at the integrand, we cannot directly integrate it, sine of tan inverse x divided by 1 plus x square. But we can see terms as tan inverse x and 1 by 1 plus x square. As you know, derivative of tan inverse of x is 1 by 1 plus x square. So we can replace this derivative tan inverse x term. So let me replace that tan inverse x term. Let me replace the tan inverse x by some variable t. So on differentiating, 1 divided by 1 plus x square dx, and this is dt. So upon substituting these in the given integral, this becomes integration of sine t dt. So once again it becomes sine t, as we replace tan inverse x by t and 1 by 1 plus x square dx by dt. So it becomes simply sine t. So what is that integration of sine t? Minus cos t. So it is minus cos t. And let me substitute back because the function given which is to be integrated is in terms of x. So answer should be also in terms of x. So it is minus of cos of t. What is t? T is nothing but tan inverse x. So as we integrated indefinite integral, so what is customary? It is to add arbitrary constant. So it is to write plus c. It is to write plus c. Likewise, no, some one another problem, integration of e power 2x minus e power minus 2x divided by e power 2x plus e power minus 2x dx. So by looking at the function, we should be in a position to identify some connection between the terms. One as can be replaced by some t and the other one can be replaced by dt. So here if you look at, now we can connect these two, the numerator and the denominator. So what is the connection? The numerator is, what is numerator? E power 2x minus e power minus 2x is differential of derivative of e power 2x plus e power minus 2x. So for that what do? We replace the denominator. So what is that? E power 2x plus e power minus 2x by some t. So let me replace that e power 2x plus e power minus 2x by t. Then upon differentiating, it is 2 into e power 2x plus derivative of e power minus 2x is minus 2 into e power minus 2x. Differentiation of e power kx is e power kx into k. So what do we have? We have e power 2x and e power minus 2x. So it is to differentiate e power 2x. Derivative of e power 2x is 2 into e power 2x and derivative of e power minus 2x is minus 2 into e power minus 2x. So with that what we are going to have on the other side? It is only dt. But here in this we only have e power 2x plus into minus minus e power minus 2x dx. So this can be replaced by dt by 2. So whatever the coefficient constant that we have 2 common for both of these two, that we can take it to the other side. So it becomes dt by 2. So it is to substitute once again these two, e power 2x plus e power minus 2x by some t and e power 2x minus e power minus 2x dx by dt by 2. So with that it is simply integration of the numerator can be replaced by dt by 2 and the denominator can be replaced by t. Numerator can be replaced by dt by 2 and denominator can be replaced by t. So it is simply 1 by 2 into integration of dt divided by t. So now how it is? It is in the form of integration of 1 by t. What is integration of 1 by t? Log t. So it is 1 by 2 into log t. And what else? It is to add the arbitrary constant c. And once again substitute back in terms of x. So it is 1 by 2 into log e power 2x plus e power minus 2x plus some constant c. Plus some constant c. So this is how we can evaluate the integral by substitution method. Let us illustrate the same with another example. Let me have an integral e power integration of e power tan inverse x divided by 1 plus x square dx. So once again what we find? We find tan inverse x and 1 by 1 plus x square. So let me replace tan inverse x by what? By t. Let me replace tan inverse x by t. So derivative of it is dx divided by 1 plus x square is equal to dt. So it becomes, the given integral becomes e power tan inverse x. Tan inverse x is t and dx by 1 plus x square dt. So it is simply e power t dt. What is integration of e power t? E power t integration is e power t only plus some constant c. And what do we have to do at the end? substitute back. What is to substitute? It is to substitute back t by, here in this case, tan inverse x. So it is only e power tan inverse x plus some constant c. So this is the integration of e power tan inverse x divided by 1 plus x square dx. So in all these examples, what we have to see, we have to connect terms there in it, as one is derivative of the other. Here in this tan inverse x differentiation as 1 by 1 plus x square. In the previous example, e power 2x plus e power minus 2x differentiation as the numerator, e power 2x minus e power minus 2x, as we find 2 is missing, so that is why we kept dt by 2 the other side. So likewise, some more example, some more problems for your practice. First one, integration of cot x into log of sin x. So it is to identify which one is to be replaced and or which one is to be differentiation of the other, whether cot x is differentiation of log sin x or log sin x is differentiation of cot x, likewise. So here in this case, it is to suppose log sin x as a t, then cot x dx will become its derivatives. Likewise, in the other examples, cos x divided by square root of 1 plus sin x, cos x into cos 2x into sin 2x, and the fourth one, cos root x by square root of x. Next, the other method, second method, integration using partial fractions. So when do we go by partial fractions? When we have something like this, 1 divided by x square plus 3x plus 2, which cannot be directly integrable. But this we can split into terms by making use of partial fractions method. So here what do we have? Here we have 1 divided by, let me consider the integrand, x square plus 3x plus 2, and this we write it as 1 divided by x plus 1 into x plus 2 as the linear factors, x square plus 3x plus 2 as product of two linear factors, one being x plus 1 and the other being x plus 2, which means upon multiplying these two, we are going to get x square plus 3x plus 2. So this, how could we write? As the linear factors, the partial fractions, we can write it as a divided by x plus 1 being the first term and b divided by x plus 2, the second term. So it is to find out the constants a and b here in this. The constants a and b here in this. On comparing the numerators, on comparing the numerator, left hand side we only have 1, right hand side it is like a into x plus 2 plus b into x plus 1, a into x plus 2 and b into x plus 1. So it is to determine a and b. So for that, what do? I'll just replace x terms. So let me put x is equal to minus 2. Then what happens? It is 1 as it is, because we do not have anything in terms of a or b in the left hand side. And on the right hand side, when we put x equal to minus 2 plus 2 will become 0. So only b term will be left as b into, when x is minus 2 plus 1 becomes minus 1. So from here you will be getting directly what is b. What is b? b is equal to minus 1. Same lines, if we put another value to x, what we can put for x? We can put x is equal to minus 1. So left hand side no change, because neither we have a nor b, it is only 1. So this time also it is 1. And what about the other side? Because we have b into x plus 1, when we put x equal to minus 1, this term vanished, 0. So we only have a term as a into x equal to what? X equal to minus 1. When we put x equal to minus 1 plus 2 will become plus 1. So from here we can write what is A. What is A? A is equal to 1. Now it is to substitute what are A and B values and integrate it. So integration of dx divided by x square plus 3x plus 2, initially we have written it as dx divided by x plus 1 into x plus 2 as the linear factors. Now with the partial fractions we could split them into two terms. One is dx divided by what is A? A is equal to 1. So it is 1 divided by x plus 1 plus b. What is b? B is minus 1. Minus 1 divided by x plus 2 dx. We find out what are the constants values a and b by using partial fractions method. So how it can be done? By comparing the numerators. On comparing the numerators, left hand side we only have 1, and right hand side upon cross multiplying a to x plus 2 and b to x plus 1, it is a into x plus 2 plus b into x plus 1. And in order to determine a and b values, it is to replace x by minus 2 and minus 1, and correspondingly we got b value as minus 1, a value as plus 1. So let me consider the given question, integration of 1 divided by x square plus 3x plus 2, and when we write the partial fractions we are going to get like this: 1 divided by x plus 1 plus into minus minus 1 divided by x plus 2. As both are in terms of 1 by x form, integration of 1 by x log x plus 1, this is plus into minus minus log x plus 2 plus some constant c. You may leave it like this, but otherwise this we could write it as log m minus log n as log m by n. What is that? Log of x plus 1 divided by x plus 2 plus some constant c. The formula which we have used here in this is log m minus log n. Log m minus log n as log m by n. So this is how we can get the integral by using partial fractions whenever it is necessary. So x square plus 3x plus 2, we have written it as x plus 1 into x plus 2, then partial fractions according. Let us discuss one more example by the same partial fractions method, but as we could see, two terms, but one of the term is second order, x square plus 1. One is linear term as in previous case, but now we see one second order, one first order. But anyhow, it is to make use of partial fractions. So let me rewrite this according to the terms in the denominator. So what is that integrand? X square plus x plus 1 divided by x square plus 1 into x plus 2. So corresponding to a second order term x square plus 1, it is ax plus b divided by x square plus 1, and corresponding to linear term x plus 2, it is c divided by x plus 2. Corresponding to second order term x square plus 1, it is ax plus b divided by x square plus 1, and corresponding to linear term it is c divided by x plus 2. So this is the thing, first step. And next what is to do? On comparing the numerators, of both left and right hand sides, we get x square plus 1, x square plus x plus 1 on the left hand side. Right hand side it is ax plus b into x plus 2 plus c into x plus x square plus 1. So it is just cross multiplying ax plus b to x plus 2 c to x square plus 1. Now comparing coefficients of x square, x and constants, we get first x square coefficient. What do we have? X square coefficient 1. Whereas left hand side we have x square here and here. Here upon multiplying to ax to x, it is a, and c to x square also one another. Next, x coefficient. What do we have? X coefficient here on the left hand side it is 1, and here upon multiplying ax to 2 it is 2a, and multiplying b to x we're going to have b. Here we do not have any x term, we only have x square and constant. X term upon multiplying ax by 2, so it is 2a coefficient of x, and multiplying b to x one another, so coefficient of x is b. So we have two terms, one is 2a and the other one is b. And what else? It is to compare constant. So what do we have as a constant on the left hand side? It is 1. And right hand side, when b is multiplied to 2, it is 2b, plus when c is multiplied to 1, it is c. And also put x is equal to minus 2 and see what happens to the expression on the left and right hand side. When we put x equal to minus 2, it is minus 2 whole square plus x value minus 2 plus 1. Right hand side, when we put x equal to minus 2 plus 2, 0. 0 into anything, 0. C into x equal to minus 2 whole square, 4. 4 plus 1, it is 3. So it becomes 4 minus 1, 3. It is 4 and it is minus 1, 3 is equal to, on the right hand side we only left with, when we put x equal to minus 2, this become 4 plus 1, 5. When we put x equal to minus 2, minus 2 square is 4, 4 plus 1 is 5. So it becomes 5c. So 5c is equal to 4 minus 1, 3. So c is equal to 3 by 5. So this can be substituted in order to find a and b. So when a plus c is equal to 1, then a is equal to 1 minus c. What is c? C is equal to 3 by 5. So it is 1 minus of 3 by 5. So it becomes minus 2. It becomes minus 2 by 5. And same lines, when we put c here in this, you will be getting b also. So as 2b plus c is equal to 1. And what is c value? C value is 3 by 5. So 2b plus 3 by 5 is equal to 1. So 2b is equal to 1 minus 3 by 5. So which is, what is 1 minus 3 by 5? It is 5 into 1, 5. 5 minus 3, 2. 5 minus 3 is 2. 2, it is 2 by 5. So when 2b is equal to 2 by 5, b is equal to 1 by 5. Now we got all the values. B as 1 by 5, A as minus 2 by 5, C as 3 by 5. So substituting all these here in this and integrating separately, you will be getting integration of x square plus x plus 1 divided by x square plus 1 into x plus 2. So what is A? A is equal to minus 2 by 5 into integration of x by x square plus 1 plus B. What is B? B is 1 by 5. So 1 by 5 into integration of 1 by x square plus 1 plus C. C is 3 by 5. 3 by 5 into integration of 1 by x plus 2. So we just substituted what are the values of A, B, C and separated the terms. So here integration of x by x square plus 1 will be log of x square plus 1. So it is minus 1 by 5 log of x square plus 1. Integration of 1 by x square plus 1 is tan inverse. And integration of 1 by x is log of x plus 2. Log of x plus 2. And what is to do? It is to add the constant. It is to add the constant. So it is plus C. So once again the same partial fractions method we applied. As we see, x square plus x plus 1 divided by x square plus 1 into x plus 2. X square plus 1 being a second order term or second degree term, we have the partial fraction term correspondingly as ax plus b divided by x square plus 1, and corresponding to another term, linear term x plus 2, it is c divided by x plus 2. So we did the same thing comparing the numerators. Why only numerators? Because denominator is the same, the product of x square plus 1 and x plus 2. Next, we on comparing the coefficients of x square and x, and also we compare the constant terms. By substituting x by minus 2, we got first c value, and substituting c value here in these two, we will be getting the other two, a and b. Substituting all these three here in this and integrating separately, we get the required. So this is how we can evaluate the integrals by splitting into terms by partial fractions method. So this is the second method to get the integration. These are two problems for your practice: x divided by x plus 1 into x plus 2, and one another 2x minus 3 divided by x square minus 1 into x plus 3. First one you can evaluate it by the first example, as we find linear terms x plus 1 and x plus 2, whereas the second one is similar to the second example where we have a quadratic, a second order expression x square minus 1. Hope you answer these two questions just as in the examples that we have discussed. Now the third method, integration by parts. Integration by parts is popular when we have the function to integrated is product of two functions. So as here in this example, you could see integration of x into cos x, integration of x into cos x. So one can be treated as u, the other one can be treated as v. So what is that integration by parts formula? Integration of uv is equal to u integral v minus integration of u dash into integration of v. Integration of uv as u integral v minus integration of u dash into integration of v. So here the algebraic function x can be supposed as u and the trigonometric function can be supposed as cos x. So integration of x into cos x as what is u? U is x. So x into integration of v. V is cos x. So x into integration of cos x minus integration of derivative of u. Derivative of u is 1 and integration of cos x. Integration of cos x. So it is just to get the integration of cos x. So it is x into integration of cos x is sin x. So first term as x into sin x minus integration of cos x is sin x. Now it is x into sin x minus integration of minus sin x. What is integration of minus sin x? Minus cos x. So generally a confusion will be there in differentiation of sin x and integration of sin x, differentiation of cos x and integration of cos x. Differentiation of sin x is only cos x, but integration of sin x is minus cos x. Similar to it, differentiation of cos x has minus sin x, whereas integration of cos x has plus sin x. So it is x into sin x minus into minus plus cos x plus some arbitrary constants. So this is how we can evaluate the integrals by integration by parts, where we could see product of two functions. So here in this case we have x into cos x. Let us illustrate with one more example. Integration of log x. Integration of log x. So as we could see only log x, but how could we apply integration by parts? By rewriting it. How could we rewrite it? We could rewrite it as log x into 1. So that log x as u, 1 as v. Log x as u, 1 as v. So once again, integration by parts. Because of the rule I late, I stands for inverse function, L stands for logarithmic functions, A stands for algebraic functions, T stands for trigonometric functions, E stands for exponential functions. Order of preference is first logarithmic, then algebraic. 1 as x to the power 0. So for that reason, I suppose log x as u, 1 as v. Now integration by parts. So u into log x into integration of v, integration of 1 minus integration of derivative of u, derivative of log x is 1 by x and integration of 1. So let me write integration of 1 first. So it is log x into, what is integration of 1? Integration of 1 is x. Mind you, integration of 1 is not 0. Integration of 1 is x. Derivative of 1 is 0. So let me substitute here also 1 by x into integration of 1 being x. So x gets cancelled. So it is x into log x being the first term minus, after cancelling the x, it is only 1. So it is just to integrate 1. Integration of 1 with respect to x is x. So that is how we could see it as x into. So what is to write at the end? It is to add a constant. So it is x common. So it is x into log x minus 1 plus some c. Likewise, you can get the integration by parts. So what we have done, we just rewrite the function log x as log x into 1, treating log x as u, 1 as v, we integrated. Likewise, one another function tan inverse x. So tan inverse x cannot be integrated directly. So this we could rewrite it by writing it as in the second example, tan inverse x into 1 dx. So treating tan inverse x as u and 1 as v, we can integrate it. So u into tan inverse x into integration of 1 dx minus integration of derivative of tan inverse. Derivative of tan inverse is 1 by 1 plus x square and integration of 1 dx. Integration of 1 dx. So let me substitute what is integration of 1. Integration of 1 is x. So it is x into tan inverse x minus integration of x divided by 1 plus x square. How come x? X is because of integration of 1. So it becomes x into 1 divided by 1 plus x square. Now integration of this second term, it has x into tan inverse x minus multiplying and dividing 2 to this. Upon integrating, this becomes 1 by 2 into log of 1 plus x square. By supposing 1 plus x square as t, 2x dx will become dt. So it is integration of 1 by t dt. Integration of 1 by t is log t. So integration is over, so we can add the constants. We can add the constant. So it is plus c. So that is how we can evaluate the integrals using integration by parts. One another problem in same lines, x square into log x. Likewise, few other x square into cos x and sin inverse x into sin inverse x dx, and one more x square into sin 2x. Just by applying integration by parts, treating one as u, the other one as v, by using the same eyelet, you need to identify which one comes first. Either we have inverse function or logarithmic function or algebraic function or trigonometric or exponential. Based on that, we can decide which one can be treated as u and the other can be treated as v, and using the same formula, integration by parts, we can evaluate the integral. Okay, so this is it for today. In this session, methods of finding integrations. One is methods by substitution, integration by substitution. 2 is by partial fractions, and third one is this integration by parts. Okay, thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.